Okay, so we have a question right here. It basically says that a child's slide has a vertical height of 1.7 meters. A child starts from rest at top of the slide and moves down the slide. The resistive force acting on the child can be ignored. Explain why the equation of motion should not be used to determine the maximum speed. You should consider the shape of the slide. So let's see the slide. If you see this slide right here, it's a bit bendy at the middle. So it means that it starts accelerating and it decelerates a bit and then it's accelerating again. So there's a change in acceleration, right? Change in acceleration, which means it doesn't follow one of the equation of motion, right? Which is that the acceleration should be constant, right? If it's not constant, then it's disobeying one of the equation of motion's rules, right? So we just have to say exactly the same thing here. We have to say the slide is curved, the slide is curved, right? And not and, so the steepness keeps changing. This means the child's acceleration is not constant, right? It's not constant, so you can't sorry you can't use the equation of motions, right? Equation of motions, right? So this is your final answer. Okay, so we have the next part here. It basically says that the child has a mass this and find the maximum speed. So if you can't use the equation of motion, you usually come to the equations that are like kinetic energy, right? So kinetic energy is equal to 1 by 2 mv square, because this is the last option you have, right, in your formula sheet. So now you don't have energy, you have mass, right? So in order to get your energy, you can use the gravitational potential energy because you have height of that slide, right? So you can use the gravitational potential energy, right? So gravitational potential energy is equal to mgh, right? This is the mass, gravity, and the height, right? So you have the mass of the kid, the gravity value, which is 9.81, and the height of the slide, which is 1.7 meters. So it's 24 times 9.81, right, times basically 1.7, and you will get your value around 400 joules, right? You should use the value of the calculator. If you have some decimals there, I have just written the value with me. I don't have the calculator right now, or else I would have written the whole value. But you should write the whole value and use that value for your next calculations, right? Don't use the rounded off values. So now we will put the kinetic energy back here. It will be 400, like whatever the blah blah value for you, and it's 1 by 2, and mass is 24, and v you need to find v square, right? So if you rearrange it, it will become 400 blah blah blah, whatever your value is from your calculator, and multiply it by 2 and divided by 24, right? V square is equals to, right? So if you put square on the other side, it becomes square root. So it's 400 blah 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 times 2 divided by 24. So if you write your value, it will become 5.77 meter per second, right? As we have seen from the previous part, that the significance they have given is in two significant figures, right, or one decimal place. So write your answer in two significant figures, right? So it's 5.78. It's not 5.78, my bad, 5.8 meter per second. Okay, so it's 5.8 meter per second. So this is your final answer. Okay, so we have the next part here. It says two slides. There are two slides, slide X and slide Y. Slide X is longer than slide Y. The child moves from the slide X, reaches here at maximum velocity here. Same thing, here goes with slide Y, another child, and it has the maximum velocity this, and basically the child Y has greater mass than child X. The resistive force can be ignored. Explain the comparison between them. So it's very simple. It's the same from the previous part. If you remember how we used the previous part, we used kinetic energy, right? And we found our V from kinetic energy, but to get the energy for this, we used gravitational potential energy, right? Usually your basically the formula sheet writes it like this: ek is equals to eg, right? The 1 by 2 mv square is equals to mgh, right? If you remember, 1 by 2 mv square is equals to mgh. We basically use exactly this, but I wrote it separately. If you just make them equal, it's basically the same thing, if you know the from the previous part, right? So we had height, and then we calculated this, and we get the energy, and we use the same energy here and get the V value, right? So now I just made them equal right here. Okay, it's very simple. So now they told us that the thing is, only the difference is there is the width and the mass, right? So let's see whether this could affect our final result, which is the maximum speed. Does it affect our maximum speed or not, right? So the heights are same actually though, okay? So they did not mention anything about the height. The height is the same, but the difference between these slight variations. So as you can see from the formula, right? Like if we cut these two, the mass is excluded. Like you don't have to worry about the mass. It was the same thing as well. I did it from the long way, so you thought like we have mass working there. But if you write it this way, you don't even need mass. Like mass is like an additional stuff for you, so you don't need it. So if you remove mass, now you're left with 1 by 2 square is equals to gh, right? So you need final velocity, so you will make v a subject, so it's v square is equals to 2gh, right? Now, if you put square on the other side, it will become square root. So it's v square root 2gh. So the only thing that could ever change anything, because g is constant, it's gravity, it's 9.81, right? So unless you're living on some other planet, this would be a big cause for you. The only thing is that the height, and as you can see, they did not change the height. So yeah, and the longer doesn't mean the height. The longer means this only. This, if you can see from the image, they have shown which side they're talking about, how longer. It's like longer from the downside, not the height itself. Okay. So the height is not changing. So basically, I think so. It's like they did not ask us to explain whether there will be any changes due to height, even if you see the mark scheme. But like I'm just explaining you what is actually happening here. Okay. So you basically have to explain all of this stuff. This calculation is important, right? You need to show this calculation, right? If you can. Otherwise, you can just write the final result here and just explain about speed. That is only if the thing that only affects the speed is the height, right? How? Using this formula, right? So I will write ek and eg, the gravitational potential energy and kinetic energy, have mass in common, right? So the velocity is not affected by the mass. The velocity is not affected by the mass, right? So by using this formula, by using the formula I've shown you, which is v is equals to square root 2gh. V, as you know, you have to mention that g is constant. G is constant. So V is only affected by h value, height, right? That's it. You need to write only these 3 points, and you will get the marks. You will get the marks easily.